Hey, 6th grade, this is Mr. Gillis coming to you with the Unit 1 review today where we talked about area and surface area all unit long. Kind of a long chapter here. Again, this is in our Illustrative Math series, so if you're watching from anywhere else in the world, this goes along with the Illustrative Mathematics series. Remember, again, for my class, you do get to use this review on your test, so it'll be a really great resource for you. With that, let's get started right away with number 1. It says a rectangular prism is 3 units high, 2 units wide, and 5 units long. I'm going to start off by labeling that. So 3 units tall, and 2 units wide, and 5 units long. If I'm looking for the surface area, remember I'm looking again for the area of each one of these faces. So I like to break it down into front and back. And then I call my two sides my right and left. And then that leaves me with my top and my bottom. Okay. And for my front and back, I'll call it these sides. It looks like it's 1, 2, 3 by 1, 2, 3, 4, 5. So 3 times 5 is 15. And then I also have a back. That's 15 for the area on the back. So 15 and 15, or 15 times 2, gives me 30 square units for the front and back. I'll do the same for the right and left and the top and bottom. The right is 2 by 3. 2 by 3 is 6. And the left is the same. So 6 and 6 gives me 12. Or 6 times 2, same thing. And then the top and the bottom, the top is 1, 2, 3, 4, 5 by 2. So 5 by 2 is 10 on the top and 10 on the bottom for a total of 20. And then the surface area is all 6 of these sides together. So again, here's the 1, 2, 3, 4, 5, 6 sides. I'll add those together. 30 plus 12 would be 42. And then 42 plus the 20 would give me a total of 62 units, since I don't have a label on there. And remember, those are square units since we're talking about area. Okay. Number 2 says, write your best definition or description of a polyhedron. So I'll kind of do both of those. If possible, use the terms that we learned about in the lesson. Okay. So first thing I know, poly means many. Okay. So we're talking about many faces in this case of a hedron, and we're talking about a 3D, three-dimensional figure that's made from faces that are filled in polygons. Remember, we said there can't be any gaps in our lines. That wouldn't be a polygon. Remember, polygon is a many-sided shape. Poly means many, gon refers to shape. Okay. Also, I'm going to mention that each face, and again, like face, like for example, would be the front of this shape or the top of this shape. Those are the faces. Meets one other face along a complete edge. Okay. Each face meets one other face along a complete edge. So in this case up here, this would be an example of an edge. This would be an example of an edge. This would be an example of an edge. Okay. And then lastly would be points where edges meet are called vertices. So for example, if we're looking back at this example, here our edges meet. That's a vertice. Here our edges meet. That's a vertice. Okay? So vertices are kind of like corners, if you will, in just common terms. So all those things represent what a polyhedron is. Basically a 3D shape made from polygons. So I'm keeping it real basic. All right, let's look at the last one here. Looks like my picture didn't quite come all the way over. Hopefully you can kind of see it on your screen. Maybe I'll pause here for just a second and see if I can change that. Okay, hopefully that looks a little bit better and you can see that a little more accurately. Number 3 says, which of these 5 polyhedra are prisms and which ones are pyramids? So knowing the difference between those. I think pyramids are a little bit easier to identify, if you ask me, because pyramids have triangular sides and they meet at a point. And I think everybody probably has somewhat of a pretty decent idea of what pyramids are because, well, we've seen so well in the world the ancient Egyptian pyramids and how marvelous they are, and we get the idea of what they look like, right? So the pyramids, the ones that have triangular sides and that meet at a point, would be letter E, figure E, and figure B. They meet at that point up there, and their sides are triangles. So B and E are the 2 pyramids here. Let's check and make sure that the other ones are all prisms. Prisms have bases that match. So in figure A, my 2 matching bases looks like they are 1, 2, 3, 4, 5, 6 sides. So hexagonal prisms, and the sides are rectangles. So figure A looks like a prism. Figure D looks like it has 2 triangles that are the bases that are matching, and then it's got the 3 sides. 2 sides being rectangles and 1 look like it's being a square. So this would be a triangular prism. And then figure C looks like it's just composed of bases that are rectangles. So this would be a rectangular prism. So figure C and A and D then would all be the prisms. Okay. Number 4 asks, what kind of polyhedron can be assembled from this net? So what I see on here is kind of if I were to take this and I were to fold it up, so that side and fold it up, and take this side and fold it up, and then I'd have these 4 faces that folded together. I would have what we call a rectangular prism, with our 2 bases being rectangles. Number 5 says find the surface area in square units of the polyhedron. So we're trying to find the surface area now of that shape. Okay, so key there being able to find the area of each one of those and then adding them together. Okay, so when I do that, the top and bottom looks like it's 1, 2, 3, 4, 5, 6. This one would match, so 6 and 6 is 12. My next sides, I could call this a 3 by 4. So 3 times 4 is 12, meaning this one would also be 12. It matches. So 12 and 12 is 24. And then lastly, I have these 2 sides, which is 2 by 4, 2 by 4. So this is 8, and this is 8, for a total of 16. So then it's just a matter of adding or summing those 3 together. So let's see, 24 and 16 would give me 40, and 40 and 12 would give me 52. Remember, it would be units squared. Okay, number 6 says, in this net, the 2 triangles are right triangles. So one thing I might do is I might add that right angle sign right there. All quadrilaterals are rectangles, so these 3 are rectangles. What is its surface area in square units? And show your reasoning. So again, I'm going to find the area of each one of these polygons and then add them together. So I'm going to start with my triangles. It looks like I have a base of 6 and that meets this height at a 90-degree angle right here. So base times height, and then I take half of it, or divide it by 2. 6 times 8 is 48, and then 48 divided by 2 is 24 units. So this triangle would be 24 units. And it looks like this is the same. So that would be another 24 units. So if I'm just kind of keeping track of my triangles, have an area, when I put them together, 24 and 24 gives me 48. So my two triangles are 48. Then it just leaves me with these 3 rectangles. So again, rectangles are base times height or length times width. So 5 times 10 is 50. And I have this rectangle, which looks like it's 5 by 8. 5 times 8 is 40. And lastly, this rectangle looks like it is 6 by 5. And 6 times 5 is 30. And that takes care of all 5, 1, 2, 3, 4, 5 faces. So when I add those together, 8 plus 0, 0, 0 is 8. 4 plus 5 is 9. 9 plus 4 is 13. And 13 plus 3 is 16. So I come up with 168. And again, I don't have a label, so it'd be units squared because I'm talking about surface area. Okay. Number 7 says if the net is assembled, which of these polyhedra would it make? So I'm looking at this net here, and I'm saying if I were to assemble it, which of these would it make? A, B, C, or D? And one of the first things that I remember is that this said that the 2 triangles are right triangles. So when I come down here and I look at my triangles, I can kind of eliminate letters B and letters D because this triangle is not a right triangle. These angles are not right angles. And the same with this one. This one here, well, maybe this could be a right angle, but if I look a little bit closer, I don't see that right angle sign. And the same actually goes here. Whereas letter C, when I look at it, this is a big hint saying, oh yeah, this is a right triangle, that 90-degree sign. But let's double check and make sure that our measurements line up with that. So is the base 6 and the height 8 of this triangle on C? Scroll down here. And yeah, it is. The base is 6 and the height is 8. If we look closer at some of the rectangles, is 5 one of the bases of the rectangles? In fact, it is. That slant height is 10. That matches with this. Okay. And it also matches with what we see for the height of this last rectangle. Okay, so this face of this rectangle is 10 by 5, which we see right here, 10 by 5. Okay. Kind of almost like the top to the ramp, if you imagine this as a ramp. So letter C looks like our guy, looks like that's the one that folds up from that. Okay, I think I'm running out of time on my video, and it looks like I need to do a little bit of rearranging over here, so I'm going to pause the video and then come back in just a second. Alright, so finishing up here with problems 8, 9, and 10. Number 8 says choose 2 figures that have the same surface area but different volumes and show your reasoning. Okay, so for this one, what I'm going to do is, I think to make it easy on myself, I'm going to say I'm going to find the surface area of CD and E. I'm also going to find the volume of CD and E. So I'm just going to make a little chart here. Sorry, it might not be the most organized chart here, but it's a little bit tricky with my Wacom tablet here, but I think you'll get the gist. So, and then I'm going to say C D, and E. And then I can compare these three and see which ones have the same surface area but different volumes. Okay. So the first thing, I'm going to do some labeling. So for letter C here, I see that this side is 2 units long. This side is 1, 2, 3 units long. And its height is 1 unit tall. And we'll do that for each one of these. Letter D is 1, 2, 3, 4, 5, 6 units long, and 1 unit wide, and 1 unit tall. And then letter E is 1 wide by 2 long by. Now I have 2 different heights, so I have this height is 1, 2, 3, 4, and notice this height is only 3. So we're going to have to kind of make sure that we're being careful with that one. It looks a little bit trickier than the other two. So for the first one here, I'm going to find the volume for each one of these. Remember, volume is length times width times height. I think that'll go pretty quick. So in this one, length times width, 2 times 3 is 6, and 6 times 1 is 6. So 6 cubic units. Remember, volume is always cubic or to the 3rd power. For letter D, I have length times width, 6 times 1 is 6, times the height is also 6 cubic units. And for letter E, the trick that I'm going to do is I'm going to break this down kind of right here. If you can visualize this as being 2 snap cubes put together, one is 3 snap cubes and one is 4 snap cubes, and then I'm just putting those together. The volume of just one of these is 1. So 1, 2, 3 for these 3, and 1, 2, 3, 4 for these 4. So 3 plus 4 is 7 cubic units for the volume. Okay, so C and D have the same volume, and E is a little bit more. Okay, I'm going to erase my beautiful artwork there. Okay, and then I'm going to find the surface area next. So surface area, remember, is the area of each side. And for our sides, sometimes it's helpful to color code. So like, for example, I could color code the front blue, and then also knowing if the front is blue, so would the back. Okay, so some people like to do like this, like front and back, and say what that surface area is. I see I have an area of 2 for my, here's 1 square unit, here's another square unit, so 2 would be for the front, and then 2 more for the back for a total of 4. Okay, and then I've got my sides. I'll color code in green. So this face right here is 1, 2, 3 units, and then also the back side of this side, the screen side, would be another 3. So that would be 3 and 3 is 6. And then lastly, I've got the top and the bottom. So this is 1, 2, 3, 4, 5, 6. So 6 for the top, 6 more for the bottom is a total of 12. So to find the surface area, I'll add those 3 together. So 6 and 4 is 10, and then 10 plus 12 would give me a surface area of 22 square units. 22 square units. Letter D, same idea. If I did the top first, that's 1, 2, 3, 4, 5, 6, plus the bottom. So 6 and 6 is 12 for the top and the bottom. Okay. I could do this side right here is going to be another 6, plus the back side of it is another 12. So 12 and 12 is 24, and then I've just got this front and back side. So that would be 1, plus the one on the back is 2. So 12 and 12 is 24, and 24 plus 2 would be 26 square units for my surface area. Okay, and then I'll do letter E. Okay, so let's do the front first. I have 1, 2, 3, 4, 5, 6, 7. And then the back side would be another 7. So 7 and 7 would be a total of 14. Plus, if I did this front side, it would be 1, 2, 3, plus this one right here will be 4. Okay, so 4 plus another 4 on the back would be 8. And then I just have top and bottom. So this top is 1, and this bottom is 1. So 2 plus the bottom 2 is 4. So I have 14 plus 8 would be 22, and then 22 plus 4 would be 26 square units. So now that I have this nice little chart, I can look back to my question and see which of these have the same surface area and different volumes. Okay, and that becomes pretty clear now. The same surface area, letter D and E both have a surface area of 26 and different volumes. This one is 6 and this one is 7. So the correct two answers would be letters D and E for number 8. Let me know if you have any questions on that. Number 9 says, which is larger, 5 squared or 3 cubed? Okay, so I think what's easiest for this is to write each of these exponential forms in their expanded forms. And what I mean by that is 5 squared means 5 times 5. 5 is the base, or the number being repeated, and the 2, the exponent, tells me how many times it's multiplied by itself. Okay, and again, 3 squared would mean 3 times 3 times 3. 3 is being repeated, and it's being repeated 3 times. So I need to multiply it by itself 3 times. So here 5 times 5 gives me 25. And then down here 3 times 3 is 9. And then 9 times 3 is 27. So which one of these is larger? I would say 3 to the third power is larger. 3 cubed is larger. The second half of that says a cube has an edge length of 21 centimeters. Use an exponent to express its volume. Okay, might be helpful for you to draw a picture. This might be a little bit tricky on my Wacom tablet, but remember, to draw a cube, you just draw 2 squares overlapping each other and then connect their corners. And this gives you a basic cube. And it says an edge length of 21 centimeters. So this side would be 21. This side is 21. This side is 21. And remember, volume means length times width times height. So in this case, I'd have 21 times 21 times 21. But it wants me to write it using an exponent. So again, 21 is my number being repeated, so that's my base number. And it's being repeated 1, 2, 3 times. So I'd say 21 to the third power, or 21 cubed. And that makes sense because that's what we have here is a cube. It's 3-dimensional. Okay. Lastly, we have number 10, and it says a cube has an edge length of 11 inches. So again, if you wanted to draw another cube and label each side 11, that might not be a bad idea. It says write an expression for its volume and an expression for its surface area. Okay. Well, I know volume is length times width times height. So in a cube, all my sides are the same because my faces are made up of squares. So I would say its volume is equal to 11 times 11 times 11, which is the same thing like we did up here as 11 cubed. Okay, so either of those would work. And then the surface area is a little bit different because in the surface area we have to find the area of one side first, which in our case, since we have a square, you could say length times width, or you could just say the side length, S, because each one of these sides is S, and to find the area it's just one times the other, so S times S, or you could call that S squared, the side length squared, times, and how many faces do we have in a cube? Well, we have 6. We have the top and bottom, the left and the right, and the front and the back. So our side squared, or length times our width, times 6. In this case, we could say 11 times 11, if each one of those are the same, times 6. And that's what it wants, is an expression to find that. And lastly, it says a cube has a volume of 7 cubed cubic centimeters. What is its surface area? Okay. So again, I think it would be really helpful to draw a picture. A couple of squares overlapped, connect their corners. The volume is 7 cubic centimeters. So that means each side is going to be 7, 7, 7, and 7, because remember, volume is length times width times height. Now this says, using this, what's its surface area? Okay, remember, surface area, I have to take the length times the width, or it could be the side squared. So in this case, side squared times 6, because I have 6 faces. So S would be 7. I would square that, and then I would multiply that by 6. So 7 squared means 7 times 7, which is 49. And then I have to multiply 49 by 6. Okay? 9 times 6 is 54. Carry my 5. 6 times 4 is 24. Plus 5 is 29. So I come up with 294, and my label would be centimeters squared. Again, I'm just finding the surface area. Area is always squared, multiplying length and width. Okay. So that concludes our review here. If you can do these types of problems, and you're familiar with these types of problems, I would say you are on your way to being prepared for the Unit 1 test. Please let me know if you have any questions on this. I'll be glad to help you. That is all for now. I'll talk to you guys later.